Hello boys and girls, welcome to another episode of FoulkesBrau. Today I thought we'd finish up with the treadmill board. Finally all the parts arrived, the parts that I could get. Obviously things being what they are with lockdown and whatever and shortages, I had to substitute some components, and where we did that, we obviously did it for better components. So what I thought we'd do is we'd run through a little bit of a, not really a tutorial, but how I go about soldering it, or soldering the components back to the board. What's easier for me might be easier for you. And then we'll put power on it, and it should light up. So let's not waste any time, let's get on to the bench. Right, so here we are on the bench. I've taken the old driver IC out, the FET/IGBT driver. It was over there, and I've just cleaned up those pads. I've taken out the old the blown diode over there, the FET and the flyback diode, as well as the fuse that went up there. So if we look at it, here's all our blown components, and over here is our replacements. So I'm going to solder first the low-lying components. That diode over there, I couldn't get a replacement for, but that's not a problem. We have a through-hole component that we can make fit there. I think it's 1N5819 or something like that. That should be fine. Just a small signal diode. Yes, 1N5819 that we can put in there. Although that'll be a through hole, we can bend it and we can mount it surface mount. And what we'll do is we'll first replace that IC, and you can see it's a surface mount component. The old component was that A3020V. You don't seem to get it anymore, but that's not a train smash. The replacement is actually a new chip. It's not transistor driven, it's actually a MOSFET driven chip. It's the TLP350. So what I'm going to do, let me just get my tips out. So to replace the IC, I'm going to use a smaller tip. To give you an idea, that's my normal soldering iron tip, and I'm going to put something in like that. So let me just swap out the tips, and then we will come back. Right, we're back, the tip is swapped. So what I'm going to do, normally what you would see, some guys recommend this, some guys do it differently. I don't. The guys will put a little bit of a solder down in one pad, tack the chip down, make sure it's all aligned, and then carry on soldering and adding flux. I don't. Yes, it can work. It's what you're comfortable with. So what I use is this mechanic UV80 flux paste. So what I'm going to do is I'm just going to open it, and all I do is I like to take a toothpick like this, get a little bit onto my toothpick. You don't need much, and I'm going to put it onto the pads. I'm just going to smear it onto the pads. Now this stuff is very, very tacky, which is nice. So we just smear it onto our pads. Not the neatest of jobs. Let's see if we can zoom in there a little bit for you. That should be fine there. And we'll do the same thing to the bottom legs. Again, I'm just smearing it over. Like I say, this stuff is very tacky. And the point of this being is I'm soldering with leaded solder. None of that lead-free rubbish. But the lead-free solder has got a resin or rosin core on the inside of the solder itself, and so on the inside of that there is a rosin core. So that is the stuff that when you heat up your soldering iron, you see all the smoke going out, and then when you try and apply the solder first to your bit and then go and try and put it on the component or the pad, it rolls off because there's no more rosin to make it stick, no more flux. And that's what we're doing here. So the idea being now is that I'm going to apply a bit of solder to my tip, a small tip. After we've tacked down our icy, not tacked it down with solder, we're going to tack it down with the tacky flux or the flux paste, and then we are going to just dab it a little bit with our solder iron tip, which will have the solder on, and that will cause the tacky flux to run. So I'm just taking the icy out. It has been rather chilly in South Africa the last few weeks. For those of you not aware, we've been having a horrible cold front. Not anything fancy for European winters, but definitely not nice for South Africa. So I've actually had the fireplace running 24/7 for the last while, because I don't like the cold, and neither do my cats. Okay, I'm just putting my anti-static or ESD wristband on out of the screen, just because we're going to be working with some sensitive stuff, and I really don't want to be have these things left, right and center. So ESD wristband is on. Good. Okay. And for those of you not aware as well, not in South Africa, we are back on the booze ban. Our government has decided that we cannot behave. So tough titty for us. We are not adult enough, responsible enough to drink. So our government has stepped in and decided that they are banning booze, because apparently there are too many accidents on the road, and that's taking up space that can be used for COVID. Okay, so what I'm doing, I'm just going to take the autofocus off. I'm just going to bring it down. I'll restart the shot and we'll zoom in a bit so you can see what I'm doing. Okay, so what I'm doing, working around the camera, and you can see I've just put the icy down onto the pads, onto the tacky flux, and I'm just aligning it just so that it's equal on both sides. And trust me when I say that this tacky flux is very, very tacky. There we go, that looks about 50-50 on both sides. And it does look lined up very nicely. Yes, that looks fine. Okay, right, so we have our IC on to the tacky flux. I'm just cleaning my tip. This is going to be a bit of a, I don't know, shouldn't be too difficult. So there we go. Here's my tip. So all I'm going to do is just put in a little bit of solder just onto the tip like that. And then what I'm going to do, let's see, how am I going to get to this? I'm going to hold down on the IC so it doesn't move. And I'm just going to bring it to that pad there. And voila. Okay, it did move a little bit because I wasn't holding it down and trying to move my head. It's alright, we can just loosen that one. And there we go. So what I'll do is I'll come under the tripod, excuse the banging and the knocking of the tripod. You just get a little bit more flux on. And I'm going to go to the alternate corner. I'm going to try and do this under the tripod leg. Not so easy. No. Okay, let's do it like this. There we go. And what you can't see, but I can see very nicely, is how the flux flows under the leg. So I'm going to just do the other legs quickly. Let's see if we can do another one. It's a bit difficult for me around the camera because I can't really see. So let me do the other ones off quickly and then we'll come back and you can see what it looks like. Right, okay, so our IC is in and I've just cleaned it up with a little bit of isopropyl alcohol. And as you can see, it didn't come out too bad with that method. On this side, obviously, I've put a little bit too much solder on the tip. It doesn't matter. It will do for what we're trying to do. And that side is a little bit better. That is actually what I was trying to get. I couldn't get it under the camera. So what has happened is that the solder paste has pulled the solder under the pad. And at the back of the pad, it will form a little fillet. And so that is ideally what it should look like. But you know what? We're soldering at home. It's not the end of the world. It's a little bit too much solder. The chip will work. Right, and the next thing. So if we remember down here, we had a little glass Schottky diode. No, I don't. I've ordered it, hasn't arrived. So what I have is this 1N5819 Schottky. So what we're going to do, I'm just going to bend the leads and we will fashion our own little replacement diode. Now the thing to remember when this comes out the bandolier, excuse me, is just to remember to cut this end lead off because, excuse me, there will be glue and such sitting on it. So let me just bend these leads to suit a suitable model, and we will come back and solder that in. Right, so we've fashioned our little diode to suit us. So let's move the board up a bit. First things first, this time around we'll do it a little bit different. What I'm going to do is just put a bit of tacky flux down, but I'm also going to put a bit of solder onto the pad. So let's just get our tacky flux and put it in. Don't need a lot here, but you know, it is what it is. So let's put in a little bit of a solder flux on the pad. Let's see if I can come underneath the tripod here. Fine, like that. Now let's get our diode. I want to make sure we've got the polarity right. I'm just going to use a come on. I'm working under the tripod and looking at the camera at the same time, so yeah, that's not working too well. So push it down, Craig, and let it. There we go. So what I'll do off the camera is just add a little bit more flux to that, a little bit more solder flux, and we can come back. Right, our little diode is in, our little discharge diode, and not the neatest of jobs, but it will do. The next thing we're going to put in, by the way, the leads that you cut off from the components, these leads, keep them. You never know when you might need them, or you want to use them as little bridge pieces in a diode, in a breadboard or something like that. As well as I find the packets that the components come in, I keep, when I'm busy with a repair, then I can group all the faulty parts into that packet, and then just whatever notes I write, I put into the packet and I tape it to the chassis of whatever I'm working on. And yeah, it makes it much easier. As well as if a friend or a colleague needs a component or whatever, it's very handy just to transport them in instead of trying to put it in your pocket. Right, so the next component, we had this fuse down here. As you can see, it's one of these leaded fuses. The fuse rating for that was 3 amp, obviously at 250 volts. It's a time delay fuse. So I'm going to just bend the leads and we'll put it in and we'll solder that in. Not very exciting, but it is what it is. It's not the most difficult things, because now we're on to the through hole part of things. So let's just get these things out the way. So let me just push it through. It is really painful with this lockdown in South Africa that we can't seem to get things, you know. RS is unfortunately their website is a bit wonky, so it'll tell you that it has the components in stock, or it's a 2 to 3 day lead time or whatever, and you order it, and then they give you pay, and then they come back with a whole spiel about, sorry, this is on back order, you'll now get it in November. And a lot of components that I've ordered have actually come back like this, so now I get them in November. Or even worse, they come back with a spiel and say, sorry, we've discontinued this, we should have picked it up. And that is painful. So anyway, our fuse is in there, so let's just solder it in. It doesn't matter which way I lean the board, no, it doesn't matter. So these are straightforward through hole components. We don't need much to do this. Very simple. Solder on one side, iron on the other side, touch it to the component, feed the solder flux or the solder through, and then take the iron away. Yeah, it's some strange mess going on here in South Africa. Cigarettes are still banned. I don't know why. And yeah, now the alcohol ban. And just the way that they are doing things is very, very strange. But anyway. Okay, we cut the leads off, hold the lead, tilt the side cutter and cut it. Don't cut the whole solder and whatever you've done there, because that will undo your work. And of course, just put your finger over it if you're cutting it and it's short, because you don't want this to fly in your eye. That can be, it can ruin your day a bit. Okay, so that gives us that fuse down there, that optocoupler, the driver for the FET, and the diode, discharge, well, acting as a discharge. If you remember in the last episode, we looked at why that diode is there. It's to discharge that FET gate charge. And then we've got this flyback dual diode there for the motor, so that we don't blow the FET. Of course, now we can't just solder onto the board, because we need to mount our FET. So what and our onto the heatsink, and put in a little bit of heat paste onto this. So what I'm going to do is I'm going to just clean this, because this is horrible. I'm just going to clean it. I'm not going to do it online, because I have to change the soldering tip for these. They are. So I'm going to go back to the bigger tip now, because we're going to be working on bigger power components. Obviously a lot more heats are going on there. So I'm going to clean the back of the heatsink and just apply a little bit of well, I'll come back when we apply the paste, because there's some stuff to be learned there. So let's just do that quick. Alright, we're back. I've cleaned the board. Let me just change the white balance there. So I've cleaned our heatsink slash mounting board, and I just want to show you something. So this board has got some standoffs, and there's a little insulator that goes down there, and the diode, the dual diode, and the FET have these insulating materials, and the bridge rectifier also has a little insulator that goes through with its screw, insulator and its screw, so that even though this is not metal case, so that the screw does, or the bolt, nut, whatever you want to call it, doesn't come into contact with the board. But I'm just lining up the standoffs, and what we can see is the FET. If we pushed the FET all the way down, I haven't soldered it in, will make to its notches, then it's pretty much the ideal height for the board. The diode, on the other hand, no, we can't push it all the way down, because, or we could, but if we put our mounting plate over the insulator, it's not going to make, well, maybe. I just feel that it's difficult from this angle. What I would suggest maybe is just to raise it a little bit, so that this backing plate has an even pressure, an even contact area over the diode for better heat distribution. So I'm going to say roughly, remember I haven't pushed the standoffs in, so what I'm going to say is, if the FET was down to all the notches and the top of the tabs line up like that, if the tops are even, with the board pushed down with the standoffs, then I believe those two contact points there would be ideal. So that's how I'm going to solder it. So what we'll do is we'll solder the FET first. Just switch my soldering iron. I'll take that out the way. And yeah, one of those days. So, to come back to this, if we solder the FET first and we soldered that, what I'm talking about, the notches, those notches there, push down to the actual PC board, I think that would be the perfect height. And then what we'll do is we'll make sure that the diode we mount at the same height like that. So then our backing or pulling or holding plate should apply even pressure over both bodies. Okay, so let us get our FET in. Again, really not much to this. Same technique. Put solder on one side, heat on one side, and we'll just move it over. So let's do that. Of course, we're going to do one leg at a time so we can align it to suit us. Oh, it's a bit difficult to get into here behind the camera, but we will do our best for you. There you go. Not enough. Okay. What we can see is not much, so I'm just going to fix that one so we can do the other two, and we'll come back and do that one. So we clean and Again, we do the same thing here. Solder, hold, pull away. Now, I wonder why this one, solder, hold, pull away. And we'll come back to the first one. Solder, hold, pull away. And what you can see is it's filled in very nicely. So I clean my iron. And ideally what we want to see is that it's flowed through a little bit to the top of the board. So can you see that? In there you can see the solder's flowed. That one's flowed quite a bit through. That one's flowed through okay, and that one's flowed through okay. So perfect. That seems fine to me. Okay. So the next one is obviously going to be our fit. So we want to get this one the same height. So that looks about right there. Same thing. Remember, I clean my iron every time before I want to use it, and then I tin it when I'm putting it back for storage. So we put a bit of solder, pull away. Let's just align it. Yeah, that looks fine. Same height. So let's just solder. Oops, I'm pushing it against the tripod. Solder, pull away. Pull away. And pull away. That looks fine. So now clean the tip. Put a little bit of solder on to protect it. Put it back in the holder. So, does that look fine? Yes, it does. Again, we can see the solder's flowed through. It doesn't look like there's any shorts, so what we will do, again, just cut off the excess on the leads. Again, you don't want to cut too deep, you don't want to cut into the solder that you've just created, because that sort of defeats the object. Now, all I do to clean this is I take a little cotton bud. I think our American readers, followers call it something else, and just a bit of isopropyl alcohol. Just clean. Again, this is up to you. I like to do it. I like it professional. And it also allows you to see easier if you've made trouble. Just be careful with the bits that are left behind. Yeah, that looks fine. So the joints are fine. Nice, and it looks neat. The problem with using the tacky flux is it will leave that residue. The isopropyl alcohol will remove most of it, but it might still remain a bit tacky. What you can do then is use a bit of acetone if you can get your hands on it, proper acetone, and that takes care of that. So let's see, our fuse is in, our replacement FET is in, our replacement flyback diode, dual flyback diode, bridge rectifier was fine, our replacement driver is in, FET driver or IGBT driver, and our catch diode is in. So that is pretty much, yep, that is everything. I think so. It looks good. So the only thing left to do is to mount this back onto the heatsink. But I think before we do that, let us get, I'm just going to put a 5 amp, I don't have an 8 amp fuse, that clip-in fuse, that 5x20 there is 8 amp rated. I don't have 8 amps here, I have it at work. But for now, because we're not going to be pulling any load, let's put a 5 amp fuse in there. We'll put AC on here and we'll see what happens. Right, let me get the AC made up and we can do that. Right, here we are. Let's see, I've soldered 2 leads on here for our AC, not plugged in yet. So if you can remember, I'm just going to get my diode, my multimeter, switch it to diode mode. If you can remember, at the beginning when we started with this, we measured across here and we had a dead short, so let's switch it to diode mode. If I short the leads, we'll have a short. So let us check. No beep. Let us swap the leads. We'll get a beep. That's normal because of our flyback. I've replaced the fuse there. So let's measure across our AC mains and see if we have a short. Nothing. Nothing good. So let's just check our flyback diode over here. If I can get in there. Okay, that is normal because of the capacitance that's in the circuit. That's fine. We want to check our drive, no short, which was pin 2 and 3. And the other way it reads, that's perfect. We're biasing the diode. So let's just put that there so you can see. So pin 2 and 3 one way, that's our LED to drive it. You can see 0.9. When I reverse the leads, open. Let's see if we get anything on. So we're driving. Great. Locked. So it's 1, 2, 3, 4, 5, 6. 6 and 7. 6 and 5, nothing. Okay, so our MOSFET driver seems to be working fine as well. Well, let's put, where are my hooks, my little grabbers? Here we go. Let's put our grabbers on. We'll switch it to DC voltage. Now, a word of warning. Please, 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 if you're not comfortable with working with voltage, don't do this at home. When I put AC on, this whole part of the circuit is going to become live. That means you will have mains voltage. Remember, it's unplugged. So it means you're going to have mains voltage. Let me just move it out the way so that everything's not in. You're basically going to have mains voltage on here. The first bit of isolation we have in this circuit is this transformer here. So yeah, that's and if you remember our circuit, the power is going through the bridge rectifier, through everything, and it's going to be ready here at those MOSFETs to fire. So let me plug it in and we'll see what happens. Oh wow, I heard the relay click and the LED came on. Good. We have no DC voltage there. We have seven volts of AC. So what I believe is that this circuit is firing the MOSFET to check if there is a motor there or anything like that. And what we can see, I don't want to put my fingers in here, that little LED came on down there, that little green LED, and the marking I can't really see very well, but that little diode over there, that LED came on up there. The silk screen says that's power. This one down here says something about DC. Okay, not a problem. So I believe our board is fixed. I don't have anything or the rest of it to drive this. Just remember, this bulk storage capacitor is going to keep the charge for quite a while. Yeah, our circuit is working. Perfect. What? Yeah, I think that is another job complete. The only thing left for me to do is now to mount this onto the heatsink, and that's boring. There's not really much to watch there. Interesting. Okay, excellent. Let's set up for the finishing shot, and then we will close out and give you the costing of what all these various components would have cost you if you were going to do this yourself. Right, boys and girls, so we come to the end of this series, the repair on the DCMD Delta Charlie Mike Delta 57P Papa treadmill control board. Few interesting little faults in it. The costing. We replaced one FET and FDA, Foxtrot Delta Alpha, 20 November 50. That will set you back 56 Rand 34 at RS Components. The dual diode, the catch diode or flyback diode, the FEP 16JT, another 13 Rand 10 cents. The fuse, the 3.2 amp fuse, 456 a fuse. The driver for the MOSFET, the TLP 350, another 52 Rand 29 cents. The diode, the little catch diode, the 1N5819 that we put in, 6 Rand 55. So excluding that, your total component cost was 132 Rand 18. Yeah, 132 Rand 18. The VAT on that, another 19 Rand, so that will give you your cost of components 152 Rand 77. Remember, you cannot collect things from RS Components, you have to pay a delivery fee of 90 Rand, so total cost of the components was 242 Rand 77 cents. Now if I did the repair, another 12 Rand 50 for sundries, and let's say a labor cost of 500, so that will give you a total cost of 755 Rand 77 cents. Now, what do these boards cost with our current exchange rate? Now, these costs exclude delivery. So this is going to eBay, AliExpress, or some place in the UK that sells them, and to try and get them. The costs I got for this board with our current exchange rate, excluding delivery, it's sitting at 21 pounds to the, or 21 Rand to the pound, 134 pounds, which will give you a cost of about 2,800 Rand, or 180 euros, which will give you about, at 17 to 1, about 3,060 Rand. That is excluding delivery. So if you could buy the board, you're looking anywhere from 2.8 to 3 or more. So our cost to repair this was about anywhere from about 25 to 27% of the value. I do not know what the shipping costs to South Africa are. I haven't bothered with that because I'm tired of ordering stuff and it gets delivered to the post office and we never get it in South Africa. So shipping costs, you could probably, if you want to DHL it or something like that, add another, I don't know. It's difficult to say with our customs guys, so you can add another, say, with customs another 5, maybe anywhere between 500 and 800 Rand. So you're looking about 3,800, almost 4,000 Rand for this board, where it cost us, with, if I had to do it in my labor component, 755 Rand. Yeah. So we had some interesting faults. We had the flyback diodes that went, we had the driving MOSFET that went, we had the driver for the MOSFET that went, we had the catch or discharge diode that went, and some fuses and stuff like that. Not the most complex board to look at, really. If you follow it logically and you take your time, you will be able to sort this board out. It seems to be quite an expensive little board for a treadmill, but I suppose it is the brains behind everything. So it might be worth your while to replace it. Like I said, we did change out components. We improved because some of the original components we couldn't get. So the FET I used is the FDA or Fairchild 20N50. So it's a 20 amp N-channel MOSFET at 500 volt rating. We use the FEP16JT dual diode common cathode. And the driver chip we changed from the A3020 to the TLP350. The TLP350, the 3020 is discontinued. The 350 is now it's got MOSFETs built in it. It's not transistorized switches anymore. Yeah. Anyway, as always, I hope you enjoyed this. I hope you had fun. It's just a little bit difficult to solder behind the camera, but yeah, we will get there eventually. I had fun finding the faults. I had fun repairing it. Till the next one, take care, stay safe, and we will catch you next time. Cheers.